Precession, Precession, and Earth gravity. So generally, if we have the equator like that, it's the equator, and this is the mean equator, and this is ecliptic at J2000. Ecliptic is the radius, is the orbit of the Earth around the Sun. It's called ecliptic. And this is ecliptic for today, ecliptic. And there are some relations between so if and this is the ecliptic equator, collides this ecliptic in angle WA. This distance is called chi A. This distance is called psi, and it's gamma. Gamma 0. Gamma is the vernal equinox at time 0, means mean vernal equinox, and this is a vernal equinox at the date, and this angle will be ecliptic angle of the date, and this is the initial ecliptic or mean ecliptic angle. So it means that when the Earth's rotation axis changes, the equator will change. And the changes of equator is like that. If they have these mean values, this one and this one, then when the equator changes, we come to another equator and another ecliptic. So then these angles can present the changes of it. The differential equation has been presented for these angles. It's the psi I dt is r psi sinus epsilon a cosine psi a r e sine chi a. And also for angle W, or do omega I a dt r epsilon cosine chi a plus r psi sine epsilon a sinus chi a. So these two differential equations represent variations of these angles in time. So if we can solve this, then we can simply come to these two angles, which are the precession angles actually. So in this angle, this equation, r psi and r psi is actually r0, r1t plus r2t2 according to Captain 2003, Captain et al. So with this, he tries to model these movements with this cubic polynomial and presented these coefficients there. And R0 is actually lunisolar contribution. So which is actually, if we write it here like this, F1 lunisolar cosine epsilon 0. So this lunisolar or f parameter can be determined in the following way. So F01 lunisolar is Km0 M0 plus Ks S0. M or S are there are some parameters that there are some constant values. 3,66 minus 6, and S0 will be 500, 210.62. So minus 6. And Km is actually has this formula 3H HM mass of the moon, flattening of the moon and earth. Yes, so M is the masses of moon, masses of the sun, 1 over F2 3, and is mean motion of the moon divided by omega is almost H big K. And H is dynamic flattening of the earth. Dynamic flattening. We can write similar formula for Ks, and it is 3H. This time, mass of the sun, mass of the sun, mass of the moon, mass of the earth, in motion of sun divided by omega, which all equal to dynamic flattening Ks. This F2 has this value. F2 is 0.999933142. They have been already determined. And this dynamic flattening, is defined like that, based on this equation. So dynamic flattening, if it is 0,1 lunisolar divided by bk m0 plus bks s0 is dynamic. And R0 will be F lunisolar cosine of eclipticity, F0 of other planets, eclipticity plus H multiplying lunisolar second or the effect plus h multiplied by J2 plus J4 geodesic pressure. So as you see, this the first issue is that you need to compute this dynamic. If you see this H is involved in all of these equations. H is dynamic flattening, which has a direct relation to C20. Let me see. So relation with C20 or with dynamic flattening is actually minus 5 radius mass of the Earth, C and C20. That's the dynamic flattening of the Earth. Then you can compute it directly from C20. And C is actually the constant part of this moment, tensor of inertia. So the point is that from this C20, you will compute the dynamic flattening. And when you compute the dynamic flattening, you will insert this inside this, the first equation, the differential equation that I wrote for you, with some initial values. So which are actually initial value for psi 1, psi 0, psi 1. The psi 1 is 5 cycle per cycle, omega 1, say second minus second, 75 cycle, and thus. So the issue is that you compute this thing, this dynamic flattening from this value, this C20, and from C20, from the dynamic flattening, you can compute this equation. For the equation, this the terms for unit for R0 from dynamic R0, and R0 will be used in the differential equation to solve this, to determine this basic angles of the precession, which are psi and omega. So that's the whole process for determining this precision. Another thing that we need to talk is an estimation of the